Special symbols which tells the compiler to perform certain operations on the variables or other operands. Okay, the variables or the values on which the operations are being performed, they are referred to as operands. Okay, there are different types of operators: arithmetic, relational, logical, bitwise, increment, decrement, assignment operators. Let's go through each of them in detail. First is arithmetic operators. So those operators which allow us to perform mathematical or arithmetic calculations like addition, subtraction, multiplication, they are called as arithmetic operators. This is the list for arithmetic operators: plus, minus, into. Yeah, for multiplication asterisk is used, division, and in order to get the remainder after division, percentage symbol is used. This is also an operator and it is called modulo operator. Okay, so you can see an example here. Here a and b are initialized with the values of 9 and 4 respectively. So when c is the command is written, I mean the instruction is given as c equal to a plus b, then we get the output as 13. When it's a minus b, it's 5. Okay, so on. For just look at this statement: c equal to a percentage b, divide 9 by 4. Okay, the quotient is 2 but the remainder is 1. So a by b will return the quotient, but a modulo b will return the remainder. Okay, this is important, keep this in mind. Second one is increment decrement operator. These are unary operators. They work on a single operand. Okay, that's why the name unary. So increment decrement operator, increment, for increment we use 2 plus, and for decrement we use 2 minus. Okay, so here we have the value of a as 10 and b is 100. Okay, so plus plus a, what it actually does, it will increase the value of a by 1, so the output will get as 11. Okay, but b equal to 100 and minus minus b, this decrement operator decrements the value of b by 1. Okay, so we get the value as 99. Okay, so both decrement and increment operator, they increase or decrease the value of the variable by 1. Okay, here the operators are used in prefix notations. We can also use them in postfix operation notation, but the difference is that in prefix notation, first the value is changed and then the value is returned, but in postfix operation, first the value is returned and then it is changed. For example, here instead of plus plus a, if a plus plus would have been written, then I would get equal to 10. Okay, plus plus a equal to 10. This plus plus a is coming because of the string. Okay, don't worry about that. So if I write a plus plus instead of plus plus a, I'll get the answer here as 10 and not 11, because at first it is returning the value of a. So what was the value of a? It was 10, and then after returning it is performing the operation. Okay, what operation? No, increment operation. So it is plus plus, so 10 plus 1, it becomes 11. So if I add another statement, another printf statement after this line, okay, to print the value of a, then I will get the value as 11. Okay, that's the difference. Like prefix means first change then return, postfix means first return then change. Assignment operators, these are used for assigning a value to a variable. Okay, so there are also different types: equal to, plus equal to, minus equal to, into equal to, by equal to, modulo equal to. Okay, so these means like a plus equal to b means a equal to a plus b. Similarly, like a divided by equal to b means a equal to a by b. A by b, it will perform the operation and store the value in the variable a itself. Okay, such operators are known as assignment operators. See here, c is assigned the value of a. Okay, so what was the value of a? It's 5, so c value becomes 5. C plus equal to a, that is equivalent to this statement, like it is c equal to c plus a, so 5 plus 5, the value of c becomes 10. So on for c minus equal to a, so here 10 minus 5, 5 will be stored in c again, so we get c. Same way the remaining also. Okay, you can go through them. If we'll provide this material, you go through the example once again, and whenever you feel like you are having a doubt, put it in the WhatsApp group. We can discuss there itself. Okay. Like, feel free to ask the doubts. uh, then next topic is relational operators. Okay, relational operators actually check like what relation is present between the two operands, like whether first is greater than the second or less than the second, equal to, not equal to, greater than equal to, less than equal to. Okay, this actually returns the value 0 or 1. It returns 0 when the expression is false. It returns 1 when the expression is true. For example, you see here, uh, in the last number are actually the returned values of the the expression in which relational operators have been used. So a equal b, or a greater than b, a not equal to b, a less than equal to b, a less than equal to c. You can see all the outputs, the last numbers are always 0 and 1. Okay, so the output of the expressions in which relational operators are used is either 0 or 1. 0 means false, 1 means true. Okay, so like here a is 5, b is also 5. So come to the third line. Is 5 greater than 5? No, right, it's false. So we get 0. You see the third line? 5 greater than 5 is 0. 0 means false. So similarly, you can go through the other examples. Here are the logical operators. Okay, so these logical operators are actually used to combine the results of two different expressions. Okay, there are also three different types: logical and, logical or, and logical not. For example, let's go to this line. Okay, a equal b and c greater than b. These are two expressions. Okay, a equal b means 5 equal 5. It is true. So this expression means 1. C greater than B, 10 greater than 5, it is also 1. So what logical AND does is that when both expressions are true, it will return true. Okay, so here both are 1, so result will be stored as 1. But if either of the like statement becomes 0, then the logical AND will give the output as false. False means 0. Okay, but what happens in the case of logical OR? If either of the statement is true, then it gives true, I mean 1. But if like no statement is true, that is if this is also 0, this is also 0, then it will also return 0 value. And in both true case also it will return true, like true means 1. Okay, what is the use of logical not? It is used to inverse the result, like if the expression result is false, then it will return true, and if it is true, then it will return false, like inversion. Yeah, bitwise operators. Bitwise operators, the operators which allow us to perform the operations at binary digit level, okay, bit level. They are called as bitwise operators. Let's go through each of them individually. Okay, bitwise AND operator. Okay, if we find the bitwise AND operation of 12 and 25, like the AND operation is done on the binary equivalent of AND and 25, 12 and 25. Okay, so the AND operation is same, like 0 and 1 will give 0, but 1 and 1 will give 1, and 0 and 0 will also give 0. So similar type of operation, if you perform on the binary equivalent of the numbers, then you will get the result of bitwise AND operation. Okay, so here you can see 12 and 25. When bitwise AND is operated, then you get the answer 8, the decimal equivalent. Okay, so here is the program. You can verify the output is also 8. What is bitwise OR? Same thing, like the binary equivalent numbers are written, and then every binary digits on every binary digit the OR operation is performed. 0 or 1, it is 1, 0 or 0, it is 0, 1 or 0, it is 1, 1 or 1, 1. Similarly for the rest of the digits. Okay, so from the calculation we are getting 29, and also from the program we are getting 29. So here XOR, okay, XOR operator means if the two binary digits at a particular place, if they are different, then it returns true, that is 1. But if the binary digits at a particular place are false, are same, then it returns false. Okay, so let's go to the first digit. So here first digit is 0, here it is 1. So 0 XOR 1, they are different, right? So the output is 1. Coming to the second digit, both are 0, so 0 XOR 0 will give us 0. So same digits means 0, different digits means 1. uh, Next one is bitwise complement operator. Okay, complement operator, it it is actually it actually inverts the binary digits of the number. Okay, so bitwise complement of 35, suppose 35 is coded as 1000111. Okay, in binary, if we perform binary complement operator, then we get like 11101100. Its decimal equivalent is 220, but bitwise complement of 35 is not 220. This is because you see the numbers are actually stored in 2's complement form. So the value obtained here, it is also present in 2's complement. Okay, and this 2's complement, it is the 2's complement of minus 36. So bitwise complement of 35 is minus 36. Don't worry, you'll be studying about the complement like one's complement, two's complement in your basic electronics in detail. They are gonna teach you very well, so don't worry. Yeah, you can remember a trick, right? Like any number n, its bitwise complement will be minus of n plus 1. For example, 35, its bitwise complement will be minus 36. Let's take negative number minus 12. So its bitwise complement will be minus 12 plus 1 minus 11, and minus of minus 11 11. So positive 11. Okay, that was about bitwise complement operator. There is something called as shift operators. Okay, there are of also two types, right shift and left shift operator. Okay, so for right shift we make use of 2 greater than symbol, and for left shift we use 2 less than symbol. Okay, for what happens in right shift is that the binary digits of the number are shifted towards the right. Okay, like here you see 0 will, these two digits, like in order to get the right shift result after the right shift operation, you can do one thing, like from the right hand side you can delete the number of steps, that is here 212 greater than 2. So here 2 is denoting the number of steps. You can just delete the number of binary digits equal to the number of like steps. So here it is 2, right? So omit these two zeros and add two zeros in the beginning. That will give you the result. Like say whatever be the numbers here, you just delete them. Like even if the number would be 1 and 1 here, so you delete them and add the same number of zeros at the left side. That will land you up in the result. Okay, that's the right shift operator. It actually shifts every binary digits towards the right, and by shifting what happens is that the zero which are actually present prior to this, here it is not shown because it is like 8-bit system. Okay, so 8-bit system, if they're shifted, the zeros prior to this will come here. Okay, so if it is shifted by 2, two zeros will come here. If it is shifted by 7, like 7 digits we have to omit from the right side, and 7 zeros we have to add from on the left hand side. If it is shifted by 8, like all we have to omit and all we have to replace by 0. Okay, but the left shift operation is quite different. Like for the left shift operation we use double less than. we have to add as many zeros as is the number of steps. Okay, so look at here the number of step is given as 1, so we need to add one more 0. Okay, this will be shifting all the binary digits towards the left, one step towards the left. In the second example, 0 step towards the left, so it is same as the previous number. And in the third example, 4 step towards the left, so you need to add 4 zeros on the right hand side. Okay, so like left shift operator of 212 by 4 number of steps will land you up in 3392. Okay, so here is the example. You can write this code in the online compiler and run it. You can verify the result that right shift by 0, so 212 is 0, because like we will not be shifting the binary digits. Okay, 0 means we won't be shifting, uh, like right shift by 0 as well as left shift by 0, both will give you the same answer.